Hi, my name is Vincent, and today I want to take a look at using implicit differentiation to write the equation of a tangent line. So we have find the equation of the tangent line to the curve xy squared minus x to the third y equals 6 at the point 1, negative 2. So to answer this problem, we have to follow three steps. Calculate dy dx, then we plug the point in to dy dx to find the slope, and then we use the slope in this point to write the equation of the tangent line. So we start this off by taking the derivative with respect to x of both sides of our equation here. So on the left-hand side, we're going to have to use product rule twice. So we start this off applying the product rule to this first term here. We're going to take the derivative of x, which is 1 times y squared, plus x times the derivative of y squared is 2y dy dx. It's important that we remember to tack on this dy dx anytime we take the derivative of a y term. Now next, we're going to use product rule on this second part here. So the derivative of minus x to the third is minus 3x squared times y, and then we'll have minus x to the third times the derivative of y, which is dy dx. And we'll have equals, and then the derivative of the right side, that's the easy part, the derivative of 6 is 0. So then at this stage of the problem, we have to move the non-dy dx terms over to the other side. So we could add 3x squared y on both sides, and we could also subtract y squared on both sides. So on the left-hand side, these two terms will cancel, and now we'll just rewrite this. This is 2xy dy dx minus x to the third dy dx equals 3x squared y minus y squared. So at this stage of the problem, to solve for dy dx, we need to factor out the common dy dx term, and we'll have dy dx parentheses 2xy minus x to the third equals, and we just rewrite the right-hand side. So to solve for dy dx, the last thing we need to do is divide both sides by this factor. So we divide by 2xy minus x to the third on both sides. So the first part of this problem we could say is done. Now we just write out dy dx. Dy dx equals, and we have 3x squared y minus y squared over 2xy minus x to the third. So now step 2, we have to plug in the point 1, negative 2 into our derivative here. So we're going to plug in, but we're going to use this notation here. Dy dx with our vertical bar, 1, negative 2. This means that we're evaluating the derivative at the point x equals 1, y equals negative 2. So now all we have to do is make the substitution. We'll have 3 times 1 squared times negative 2 minus negative 2 squared over 2 times 1 times negative 2 minus 1 to the third power. So once again, all we did was replace all the x's with 1 and all the y terms with negative 2. So we just followed the order of operations here and simplify this. So in the numerator, we're going to have 3 times negative 2 is negative 6 minus negative 2 squared is 4. And now this is over negative 4 minus 1. This gives us negative 10 over negative 5, which simplifies to positive 2. Okay, so this part here is very important. This completes step 2, and this represents the slope of the tangent line, where the tangent line is meeting the curve at the point 1, negative 2. So then to close this problem out, step 3 here, we're going to use this equation, y minus y1 equals m times x minus x1. So if we plug in, think of this as our x1, y1, and this here is our slope. We're just going to plug in. We're going to have 2 times x minus 1 in parentheses equals y minus negative 2, which will change to positive 2. Now, most classes, they'll let you stop here for doing a problem that takes this long. But if you distribute this through, you'll have y equals, this will be 2x minus 2, and we subtract another 2, it'll be 2x minus 4, which is the equation of our tangent line. Okay, well, this is going to conclude this video on writing the equation of a tangent line. Thank you all for watching, and I hope that this was helpful.